Hey guys, welcome back to part 2 of the semester exam review. On this video, we are going to do questions 11 through 26. So let's get ready and go. Let's start with question 11 today. We're going to order the following numbers from greatest to least. This is really important. So make sure during your test that you are checking to see what order they want it written in. So first thing you should notice is that we have all different forms of writing numbers. We have fractions, we have decimals, and we have percents. And what we know about these is they all can be changed into one another. They're all related to one another. So what we are going to do is decide, what do I want them all to be in? Well, I know personally a lot of people like to change everything to a percent. Or change it to a decimal, whichever one makes more sense to you. So I'm going to go ahead and change each of these to a percent. So if I have 75 hundredths as a decimal, I know that I can move the decimal twice, and this would be 75%. 40% is already a percent, 1/5. So I can write 1/5, and I need it to be out of 100 for it to be a percent. So this would be times 20. So 1 times 20 gives me 20 out of 100, which we know is 20%. 1, we can move decimal twice. That gives me 100%, because if you have 1, you have a whole amount. And then we have 2/3. Well, 3 doesn't go into 100 equally, so we can divide to change it to a decimal. Remember, the numerator goes on the inside. Okay, and so 3 cannot go into 2, so we add a decimal in our 0. 3 goes into 26 times, which gives me 18, with 2 left over. Add another 0. And you should start noticing, oh, it's going to repeat because it keeps giving me a leftover of 2. So we could say that this is 66 repeating, and as a decimal, we could say this is approximately 66%. And then we have 90%, and then our last one, we move the decimal twice, we have 5%. So we're going to look, which percent is our greatest? This 100%, which relates to the number 1. So this would be your first number. Next, you have the 90%. Then you have the 75%, which is the 75 hundredths. Notice I'm writing it back in the original form that the number was written in. And then after 75, we have the approximately 66%, which is 2/3. And then we have the 40%. We have 1/5 because it's 20%. And then we have 5 hundredths, which is our 5%. And now they are in order from least to greatest. Next, we are plotting decimals on a number line. So first we have to figure out what is the number line counting by. So if we look, it's going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it takes 10 to get all the way to 1, that means it's counting by tenths. So you should think of this as 1/10, 2/10, etc., all the way through. So if I need to get to 75, I would need to count all the way to 7/10 and 8/10, because this 7/10 is the same thing as 70 hundredths, and 8/10 is the same thing as 80 hundredths. So the 75 hundredths would fall in between these two. So that would be right here. So the A would be there. 1 and 4/10, you would think here's 1, 1/10, 2/10, 3/10, 4/10. So 1 and 4/10 for B would be right there. Next, we have 6/10, which we can clearly see is right here. 2 and 2/10 go over to 2, count 1/10, 2/10, here is 2/10. So D would go there. 29 hundredths. So once again, you should be thinking, okay, 2/10 is the same thing as 20 hundredths, and 3/10 is the same thing as 30 hundredths. So the 29 hundredths is going to be pretty close to here. So here's 3/10. So we're going to say it's about right there. And this is an E, not a C. Okay, and then we have 1 and 55. So we're going to count to 5. 1, 2, 3, 4, 5, but it's going to be halfway in between, so F should fall right there. Question 13. The table shows the time in seconds for each swimmer in a race. Rank the swimmers in order from fastest to slowest. Okay, so remember when we were talking about decimals, fastest meant the lowest time because the faster you in the race, the quicker you are. So if I'm looking for my lowest time, they have these nicely organized for you where the decimals are already lined up. So I know it's not any of my 45s. So then I go look at my 44s and I look at the place value, the next place value. So this one has a 0, this one has a 3, this one has a 7, this one has a 4. So this one was the lowest. So this one made first place. And then you had the 3, so that made second place. So then the 4 make third place. And then the 7 made fourth place. Now you can look at the 5s. So we're going to draw our line at the 10th place. Okay, we have 2 in the 10th place that both have a 1. So then we go to the next one. This is 12 to versus 13. So obviously the 12 is faster. So this is 5th place, 6th place, and then 7th place would be this one. Okay, on question 14, you are asked to fill in the table, rewrite each fraction as a decimal. They put the part in the middle. A lot of people are getting thrown off by this power of 10 as a misunderstanding. So a power of 10 just means 10, 100, 1,000. They want the denominator to be one of those. So for this example, we can change 20 to be out of 100. 5 times 20 gives me the 100. So 9 times 5 gives me 45. So this would be 45 hundredths, which you would write as the decimal as 45 hundredths. 5 you can multiply to be out of 10. Okay, so this would be times 5 and times 5, which is 8 tenths, which you know is 8 tenths. The reason they're making you write it out of 10 is because of place value with decimals. Because you have your tenths place, your hundredths, and I'm going to run out of room as I write this. Okay, and then you have your thousandths. Okay, so 25 we can make to 100. Times that by 4, times 21 by 4 gives me 84. So this would be 84 hundredths. 5/8. So 5/8 is one of those that I would simply divide to come up with the decimal, but it actually is out of 1,000. 8 can multiply into 1,000, but we're going to go ahead and divide this because I know that's what most of you are doing. So remember, numerator and denominator. The numerator goes on the inside, denominator's on the out. 8 goes into 5 0 times. 8 goes into 56, gives me 48. 2 left over, add another 0. 8 goes into 20 2 times, 16. 4 left over, add another 0. 8 goes into 40 exactly 5 times. So what this means is this is 625 thousandths because my decimal is 625 thousandths. And lastly, you have 95 to get to 500, so this one's also going to be out of 1,000. Times 2 times 2, 95 times 2 is going to give me 190. So this would give me 190 thousandths, or you could just write it as 19 hundredths. In this next one, you are just writing the equivalent fraction for each of the following. So remember, the rule for fractions and ratios is what happens to the denominator must happen to the numerator to stay equivalent. So if this 3 became a 12, that multiplied by 4. So I would also need to multiply this 2 by 4. So 2 times 4 is 8. Okay, 16, well 25 became 1, so we divide by 25. And then 50 divided by 25 is 2. 45 going down to 15 was divided by 3. So 24 divided by 3 gives me 8. Okay, next we are looking at dividing fractions. So this is where we learned about multiplying by the reciprocal, and we came up with a cute little catchphrase, copy dot flip. So we're going to copy the 3/5. We're going to multiply by the reciprocal, which means we're going to flip this to 8/7. And then we multiply straight across. 3 times 8 is 24. 5 times 7 is 35. And that should be your final answer. Question 9 is same thing, dividing. So our catchphrase, copy dot flip. So 5/9 will stay 5/9. Change this to multiplication, becomes 6/1, which gives me 30/9 by multiplying straight across. Okay, but then this is an improper fraction, so we need to actually simplify it. So we're going to say, how many times will 9 go into 30? It'll go in there 3 times. Gives me 27 with 3 left over. So it went in there 3 whole times. I had 3 9ths left over, and which could also simplify to 3 1/3. Okay, let's take a look at number 20, but first notice this time we have an improper fraction. And we need to change, a mixed number, we need to change it to an improper fraction. So remember we talked about how we multiplied the denominator and we add the numerator. And we kind of saw that, oh look, it's a T and an X, so it kind of looks like Texas. It reminds us of Texas. So we're going to leave the 5/7 alone and the division sign for now. 1 times 14 is 14, plus that 1 is 15. So I have 15/14. Now I can do copy dot flip. Copy the 5/7, change this to multiplication, and we are going to flip this to 14/15. So then I have 5 times 14, which is 70, and then 7 times 15, which is 105. And we notice that I can divide both of these by 5, which gives me, this will be actually 14 again, and if I divide this by 5, it's 21. Then I notice I can still divide them both by 7, which gives me 2/3. Okay, on number 21, we have another mixed number. So once again, we are going to change this. We're going to change this to improper. So 3 times 4 is 12, plus the 3 is 15. So I have 15/4 divided by 5/6. So copy dot flip. So 4/15 times 6/5. And then we can multiply. 4 times 6 is 24. 15 times 5 gives me 75. And 3 can actually go into both of these. If you're not sure, always just try a number. 2 wouldn't work, so then I would try 3. So if you have to think, 3 goes into 75, it'll go in there 2. 6, 15, so it'll go in there 25. So the final answer should be 8/25. Okay, question 22. Use the fraction strip below to show that 2/3 is equivalent to blank 6. So here it would be 2/3, so that would be 1, 2, 3, 4, 6. And that's all you had to do on that problem. Okay, 23. I do not know how to say this name, so I'm just going to say Kaivani is making a healthy after-school snack of ants on a log using celery, peanut butter, and raisins. She has 15 celery sticks. She has already, so that's probably important that she has 15 celery sticks. She has already finished putting the peanut butter on 1/3 of them. Okay, how many ants on a log has she made? So remember we talked about when we see 1/3 of, we should be thinking about multiplication, because when we divide by a fraction, we're trying to find how many fractions are in the 15. But this one, we're wanting it to break it into thirds. You could actually visualize this one by drawing the 15 logs. That should all be the same size, but of course, when I'm drawing, that never happens. So we have 12. Let's do one more set. So if you think about, she only has made 1/3. Well, this section would be 1/3. So she made 1, 2, 3, 4, 5. Mathematically, this looks like 15 times 1/3, which we changed to 15, and so it's 15/3, which is 5. And a lot of people think, oh, well, I need to divide. Well, if you think about it, 1/3 is dividing by 3. So you could always do 15 divided by 3, because when you're wanting 1/3 of something, you're breaking it into 3 sections. Okay, number 24. We are going to compare 8/12 and 3/4 and 5/8 and 6/6. So the way we're going to do this one, we're not going to make fraction strips. It says or another method. So we're going to do common denominators on these. So 8/12, I could change the 4/3 to be out of a 12. So times this by 3 gives this the 12, times 3 by 3 gives me 9. So you can clearly see now that 9/12 is greater than the 8/12. So then we have 5/8 and 6/10, which we know we could both make them out of 80. So to change 8 to an 80, I'm going to multiply this by 10 and multiply this by 10. So this would be 50/80ths. And then to make 10 and 80, we're going to multiply it by 8. So we need to multiply the 6 by 8, which is 48. So you can clearly see that the 5/8 is greater than the 6/10 when you make a common denominator. Okay, we got 3 more. So 2/3 to 5/6. So we can change the 2/3, multiply it by 2, gives me the 6. So we have 4/6 and 5/6, so 5/6 is greater. Once again, we can multiply 4 by 3, so this becomes 6/12, so 7/12 is greater. And then 8 and 12, you have to find a common denominator. And if you think about 8 and 12, you could think about 24. So I can times this by 2 and this by 2. This becomes 24/6. Times this by 3 and this by 3, and I get 9/24. So you can tell that 3/8 is greater. You could also look that we have 8 and 12 because these two are the same. If you think about pizza, you get 3 out of the 8 slices or 3 out of the 12. Well, 3 out of 8 are bigger slices because you're not cutting the pizza up as much. Okay, on question 25, you are placing the decimal in the correct place. So they've worked it out, but then they don't have a decimal. So if we notice in this one, we have 2 decimal places and 3 decimal places. Adding is, however, not like multiplying fraction or decimals. So if you actually think about working this out without working it out, you remember that, oh, when I'm adding decimals, I line them up. So then look at how many places do I have after. You have 3, so there should be 3 in your answer, so your decimal should go there. Same thing with subtracting, you would line them up. Well, you have 3 numbers behind your decimal, so there should be 3 behind the decimal, so it would have to go there. Okay, C and D, same thing. But remember, now we are multiplying decimals. So on this one, we have 1, 2, 3, so I would have 3, and the way you can check on these is multiply the whole numbers. 3 times 9 is 27, so that's the only place that would make sense for the answer to be. Okay, and this next one, same thing. If you think about this, 28 divided by 8, that's going to be close to 3, so my decimal would need to go in between there. So just thinking about actually just solving the whole number will help you place your decimal. Okay, on 26, Miss Cease, I guess, is grading math tests. A student's work on a problem is given below. Explain, is the student correct? Explain. So if we look at this, we see we have 2 behind the decimal and 2 behind the decimal, and there is 5 behind her decimal. So no, she's incorrect. The student's incorrect because she has too many decimal places. She has 5 and she only needs 4 numbers behind the decimal.